Good morning, ladies and gentlemen. Welcome to day 1 of week 3 of distance learning, and welcome to the first new chapter of this experience, and that's chapter 15, which deals with the atmosphere. Now, I'm sure you've heard the term atmosphere, or at least familiar with it to some degree, but I want you to think about this main idea that is covered in Unit 5 as a total, and that is, how is air and advertising connected? Remember, Unit 5 is dealing with Earth's air and water, so just think about that question. How are air and advertising connected? And see what comes to mind as you're listening to the lecture as I go along. All right, let me move on to some of the main ideas that will be covered in section 1 of chapter 15. That's Earth's atmosphere. And under that category, we'll cover the importance of the atmosphere, the composition of the atmosphere, the layers of the atmosphere, atmospheric pressure, temperature in the atmospheric layers, and lastly, the ozone layer. All right, now let me go ahead and quickly mention the learning objectives that I hope we can accomplish as we go through Chapter 15, Section 1. Keep in mind, we'll probably be covering this section in total. It will take us at least this week. If we need some time next week, we'll certainly cover that as well. So Objective 1 is identify the gases in Earth's atmosphere. Objective 2, describe the structure of Earth's atmosphere. And Objective number 3, explain what causes air pressure. So those will be our objectives, identifying the gases in Earth's atmosphere, the structure of Earth's atmosphere, and then explaining what causes air pressure. So let's go ahead and let's get into the importance of the atmosphere. Earth's atmosphere, which if you look at figure 1, which I know normally you would have your textbook, and I'll try to see if I can get an image of that, is a thin layer that forms a protective covering around the planet. So the atmosphere, what is it? In basic, it's a thin layer of air, and it's around the Earth, okay? And it provides protection. It's a protective covering. It protects us from solar winds, ultraviolet radiation, and that's just a few things, not to mention probably, like I should have mentioned as well, asteroids and comets. Now, take this into consideration. If the Earth had no atmosphere, days would be extremely hot and nights would be extremely cold. Now, you may say, well, I feel like I'm cold at night, or especially during the summer, I'm really, really warm. But what we experience is nothing in comparison to the fact that if we did not have an atmosphere, how much hotter it could be during the day and how much colder it would be at night. Just think about that. Earth's atmosphere is beautiful in that it maintains a balance between the amount of heat that it absorbs from the sun and the amount of heat that escapes back into space. Now, it also protects life forms from some of the sun's harmful rays, and I mentioned that already. That would be the ultraviolet rays. There's UVAs, UVBs, and I think there might be a UVC. I'm not 100%, but I believe at least there's multiple categorizations. Now, if you look at both slide 8 and 9, you'll see a little picture. In slide 8, it's kind of small, but in slide 9, it's a little bit bigger. But on slide 9, it shows just this graphic of what's called the ultraviolet rays, and it's giving UVA and UVB, and there's, I think, one other one that talks about sun protection in general. And the little pink graphic below it is representing your skin. So as you see, UVA can go all the way down to the dermis. The UVB stops at the epidermis, and then the sun protection, when you put that on, like a SPF or some kind of protection, it actually causes the sun rays to bounce off as opposed to be absorbed. Now, if you look at UVA and UVB, if those go in and you don't have the protection, that's what can lead to forms of skin cancer. Just wanted to quickly mention that out. Then I also wanted to take a look at slide number 10, where there's a little graphic of the percent of how much harmful UV rays are blocked. Starting with a single pane window is 7%, and at the other end you have these much stronger forms of glass, like an Ultra AR 90 and an Ultra KR 90. Those are, by the way, referring to, I believe, periodic elements that are used to help block the UV rays. So it's kind of interesting to think about how we've actually developed means to help protect us in that way in regards to glass, like think more like your windows and such. Alright, so we've talked about the importance of the atmosphere. Now let's cover a little bit in brief the makeup of the atmosphere. Now, Earth's atmosphere is a mixture of gases, solids, and liquids. So 3 of the well-known states of matter and the ones that are most common to us. So the atmosphere is made up of gases, solids, and liquids. And those gases, solids, and liquids surround the planet. They extend from the surface of Earth all the way to outer space. The atmosphere is much different today from what it was many years ago. Now, how long ago and such, we're not going to get into that, but we can definitely tell that our atmosphere has changed to some degree, and just keep in mind that we shouldn't be surprised considering the activity that goes on both in our planet that we've done, as well as stuff that happens externally as well. All right. The Earth's atmosphere has a layer of ozone. Okay, you've probably heard of the ozone layer, and we'll get into this in more detail later in this section. But ozone is categorized. If you were to write it using the elements, it would be O3. Now that's unique to us because we don't usually see O3. In fact, what we're usually most common with is H2O or even O2. O3 means there's 3 oxygen atoms connected together, and that makes up ozone. Well, this ozone layer protects the Earth from the sun's harmful rays formed in the upper atmosphere, so that's much, much higher up than where can go, or what I mean where we can go is where we can go without assisted means like a plane or a spaceship. This protective layer has allowed, keep this in mind, it has allowed for us to have the green plants which flourish on Earth, which provide food and other variety of support to the planet and life itself. Because think about how much we eat, how much the animals eat, and just other things that plants do help as well with in regards to life. All right, so let's get a little bit deeper into the makeup of the atmosphere, gases in the atmosphere in particular. Now, the atmosphere is a mixture of gases, okay? Figure 2 in the textbook has this, and I'll try to post a picture if I can later today. Nitrogen is the gas that is the most abundant in the atmosphere. It makes up around 78% of the atmosphere itself. Now keep this in mind. Here's an interesting thing. Considering when we think of the air, the atmosphere, we think of oxygen. Well, oxygen only actually makes up 21% of the Earth's atmosphere. That's less than 1/4 of the Earth's atmosphere. Just keep that in mind. So if you've noticed, now we have 78% nitrogen, 21% oxygen. So you put those numbers together and you get 99%. Now the remaining 1% is made up of, as you can probably see from the graphic on slide 13, is argon, carbon dioxide, but then there's some other things. It says all others. There's other ones that come up in very small amounts. Okay, now as much as 4% of the atmosphere is water vapor. Just keep that in mind. So we talked already about the gas, now we're talking about liquid, right? Other gases that make up Earth's atmosphere include argon and carbon dioxide. I did include some images just indicating, trying to visualize at least argon, because that one's probably not as familiar to people. All right. Now, one other thing I want to include and then kind of close out for today on our lecture is just continuing with the theme of gases in the atmosphere. The composition of the atmosphere is changing in small but important ways. And what I mean by that is, there's an example your textbook uses, which is easy for us to be able to connect to our thoughts because we've seen it before. Cars, when they're driving, they emit gas out their exhaust pipe. You've seen it, like that grayish, white, dark looking stuff coming out. Well, that's one way that our atmosphere is changing because we're affecting things, because obviously when we put out chemicals, those chemicals have an effect on the Earth itself. All right, ladies and gentlemen, this should conclude our first of 5 lectures this week. We'll have one a day. If you have any questions, feel free to send me an email or even leave comments below in the video. Be excited to read what you have to say, and if you have any questions you want to ask me, that's one way I can reach out and see questions, and I'll even answer them in the comments. But you can also reach out and send me emails or chats on Google. All right? Have a nice day, and I look forward to seeing you guys later today during office hours. Goodbye.